and welcome everyone. We're really glad to have you here. We're going to spend the next hour or so giving you an introduction to the new Vulkan 1.0 API that was launched just a week ago on the 16th of February. And the last time the industry had the launch of an open standard graphics API was OpenGL, which is almost 25 years ago. And so this is a once in a generation event. So again, we're glad to have you here. So we have just an hour. We don't have time to go into an in-depth technical programming tutorial, but we hope to give you a good overview of the goals and the design of Vulkan, and to show you where the resources are that you can begin your own voyage through the Vulkan ecosystem. We're also very happy to have Karen, the CEO of LunarG, who's going to give you an overview of the LunarG SDK for Vulkan, which is the primary tool for developers beginning to use Vulkan right now. And then, as Kathleen has said, the most interesting part of this webinar, we hope, will be the Q&A, where we're looking forward to answering any questions that you have. If anyone is not familiar with Khronos, just a word about who we are. We're an open industry consortium. We have over 100 companies, and our mission is to create these royalty-free, open standard APIs to enable software developers to access accelerator silicon for functionalities such as graphics, parallel computation, and vision processing. We're an open organization. Any company is welcome to join. If what you hear here today is of interest to your company, no, please do consider joining Khronos if you'd like to. So Vulkan, where did Vulkan come from, and how did it start? Well, it was about 2 years ago where really a number of the members inside Khronos began to see the need for a new generation API to enable new classes of end user experience. And that realization was really greatly helped by having a lot of the games engine developers participating in the Khronos working groups for the first time. And the games engine vendors were really one of the main catalysts to encourage and inspire Khronos to create this new generation of API. We started design in detail about 18 months ago. We've had many significant contributions and design effort from all of the working group members that you see here on this slide. It's really been a very high energy effort, very positive, fast effort. I'd like to thank Tom, who's the working group chair, and all of the companies represented here for really getting this done in an amazingly short amount of time. So the Vulkan launch last week was the first hard launch that Khronos has done, and that means that it wasn't just the specification being uploaded, it was a specification plus a lot of other materials and drivers. So we launched the specification, full conformance tests, the LunarG SDK, all of which are in open source. We also have a full set of reference materials. There are compiler front ends also in open source, samples and demos, even applications are shipping with Vulkan backends. And most importantly, perhaps for developers, there are multiple conformant drivers shipping on multiple OSs from multiple vendors. So you don't have to wait. You can download Vulkan and get developing right now today. So what was Vulkan trying to achieve? If you look back for when OpenGL, the previous generation API, launched 25 years ago, the world was a very different place. Now, OpenGL is not going away, and Khronos is actively evolving OpenGL and OpenGL ES, but there's definitely the need for a new approach to an API that complements the well-proven OpenGL. From a hardware architecture point of view, GPUs are becoming increasingly programmable, increasingly compute capable, and the platforms in which they're running are becoming more mobile, more memory unified, and multi-core. And if we look forward, I think GPUs are going to play a key role in accelerating many emerging platforms and opportunities: robotics, autonomous vehicles, augmented reality, virtual reality. And GPUs are going to be called on to do not just graphics, but compute, vision, and deep learning acceleration across a wide diversity of platforms. So flexibility and portability are really key in this new generation. So the Vulkan API, the key goals we set ourselves was to create an explicit API, and we'll explain what that means. But it means letting developers get much closer to the GPU, not being forced to go through a thick driver stack to get to the GPU functionality. We want streamlined drivers that can provide faster performance, lower overhead, less latency, particularly important for virtual reality. We want it to be portable across a range of platforms, everything from supercomputers and cloud through desktop, console, mobile, and embedded systems. Historically, we ended up with OpenGL and OpenGL ES. In this generation, we want to make sure Vulkan is flexible enough to cover all of those platforms with just one API framework. And then last but not least, extensible. This is something we want to retain from OpenGL. One of the strengths of OpenGL is that it's extensible, and this allows hardware and software vendors to innovate at their own rate, not waiting for a platform to catch up to their needs. And just like OpenGL, Vulkan is an extensible API to be an effective platform for that innovation. So how does Vulkan achieve those goals? Well, if you look on the left, this is the thick driver model for OpenGL and OpenGL ES. If you have an OpenGL driver, there's a lot of functionality in the driver. It can be good. I mean, it's a lot of functionality that a lot of people find a lot of value in. There's a lot of context and resource management. The memory is being managed for you behind the scenes. There's a full GLSL compiler. So a modern GL driver can be actually many millions of lines of code. But that can mean that there's a thick layer between the application and the GPU. And one of the fundamental design points of OpenGL is that it's really single-threaded per context. It's hard to write a multi-threaded OpenGL application and get application speed up. Now, both OpenGL and Vulkan, they're still aimed at the same GPU. Both APIs are designed to give access to all of the functionality of an OpenGL ES 3.1 or OpenGL 4.x GPU. But Vulkan is designed to give you access to that GPU with a lot more flexibility and a lot more direct control. We do that with a much thinner driver and hand a lot of the responsibility for all of that functionality, like multi-threading and resource management, memory management. We hand that responsibility to the application. This means we have a lot simpler drivers. They can be a lot more efficient and performant. We're reducing CPU bottlenecks through having less driver load on the CPU, lower latency. And because the driver is thinner, it can be more portable across different vendors and across different operating systems. And there's actually an advantage to the right kind of application to giving the responsibility for all of that resource and thread management to the application. It means that less code is hidden behind the driver black box interface. And for applications that are willing to put the investment into that amount of code, it means that they can manage the resources and the memory in the system precisely how they need and avoid surprises and hitches and hiccups in the running of an application. Vulkan has the concept of command buffers, which means you can create command buffers separately to submitting work into the GPU. That means it's very straightforward to use whatever multi-threading scheme you want to create command buffers in parallel, using multiple cores in multi-threaded code for increased performance if the CPU is the bottleneck in your current application. Vulkan also has the concept of multiple queues, graphics compute and DMA queues that can be used together to give you much more flexibility on how the application dispatches work into the GPU. And finally, there's a couple other pieces of a driver that we've taken out of a Vulkan driver. The compiler front end for the shading language. Initially in Vulkan 1.0, it's still the familiar GLSL. The front end of the compiler is taken out into a separate package, and the Vulkan driver only understands how to absorb Spiritbe. Spiritbe is the intermediate code that's been defined by Khronos. This means the driver becomes a lot simpler, and developers can use their favorite front end, and it gives us a lot more flexibility for using alternative shading languages in the future. And last but not least, Vulkan has a loadable layer architecture, which means the driver has to do no error checking. If you're developing an application, you can load up debug and analysis tool as layers, so you can have very effective tools as you're developing, but you don't have to have the overhead of that checking when you have a proven production application. And Karen will talk more about that, how they exploit that in the LunarG SDK. So Vulkan is not the only new generation API. There are actually 3 APIs in the industry. I'm sure many of you are familiar with DirectX 12 and Metal. The key thing about Vulkan is that it's cross-platform and not controlled by any one platform vendor. So DirectX 12 only runs on Windows 10. Metal is only for Apple platforms, whereas Vulkan already has support for many different versions of Windows. From an engineering point of view, it can ship from Windows XP up to Windows 10. It's already have support for running on multiple OSs, from SteamOS, Ubuntu, Red Hat, the Linux distributions, Tizen, which is the mobile OS from Samsung, and last but not least, Android. Google have publicly committed to make Vulkan a native GPU API in a future version of Android. For software developers, Vulkan means that you can run your application in more places for better business with less porting effort. And it's interesting to compare the different APIs. Vulkan and DirectX 12 are quite similar. They're at a similar low level of abstraction. Metal is a little different. Metal retains more of the OpenGL framework, and it actually adds some OpenCL traditional framework. It means that going from an existing OpenGL ES application is actually easier to go to Metal because it's not quite so unfamiliar, but the performance gain is potentially less. If you want to put in the work to go to Vulkan or DX12, the performance gain is potentially higher. And the feedback we're getting from the games engines and advanced application developers is that the no compromise approach is the right one. Vulkan is not replacing OpenGL ES. It's enabling higher performing, smoother performing applications. And so being no compromise, low level API is the right approach. We're getting a lot of positive feedback from the developer. But Vulkan is not necessarily for everyone. To use Vulkan is more work. Because the driver is so thin, the application has to take on more responsibility. And in many cases, that extra work may not give you any advantage. So it's critical as a developer to understand whether or not Vulkan is going to give you any performance or functional advantages. Many developers will find that OpenGL and OpenGL ES are actually still the best choice, easier to use and give them good performance. But if your application is currently CPU bound and you can parallelize the work, the work to create the command buffers, then Vulkan potentially can give you, worthwhile and good speed up. Also, if you're trying to create an application that's very smooth, no glitches or hitches, for example, a virtual reality application, and you're willing to put in the effort to manage your own resources and have control over precisely how work is fed into the GPU, then again, Vulkan can enable a new class of high-quality end-user experience that it really isn't possible to do with OpenGL. But on the other hand, if your application is already maxing out the GPU, the CPU is not the bottleneck, and you're not getting any glitching problems, then OpenGL and OpenGL ES are still going to be there for you to use, and no one is going to force you to move to Vulkan. We're trying to be very straightforward about when people should use Vulkan and when they should stick with the traditional APIs. Many people, though, are going to get benefit from Vulkan without actually having to code any Vulkan code at all. Applications can use Vulkan directly for the reasons we were just outlining. But of course, as we said at the beginning, one of the key driver communities has been the game engine vendors who really want Vulkan to make sure that the games engines can extract every ounce of performance out of different and very diverse platforms. And applications that use a game engine, such as Unity or the Epic Unreal Engine, Valve, they will just be able to enjoy the game engine running faster and better without changing any of their own code. We're also very interested to see how, over the next few months, the middleware ecosystem for Vulkan evolves. We think there's going to be a rich layer of open source middleware, and Khronos is doing everything we can to help catalyze and enable that middleware ecosystem. We think there's going to be utility libraries, portability libraries, things that make Vulkan easier to use, more familiar to an OpenGL programmer. And we want to encourage this middleware ecosystem to evolve as quickly as possible. We call it a three-layer ecosystem because there's the middleware in between the hardware and the application. And we've seen this shape, this class of ecosystem work well before with WebGL, where WebGL is a very low-level API, lower level than most web APIs, but its flexibility has enabled a very rich JavaScript ecosystem in the case of WebGL. And so there are many WebGL apps. Very few of them actually use WebGL directly. Most of them will go through a middleware engine. And we think perhaps the same thing will happen with Vulkan. I want to mention Spiritbe. Spiritbe, in many respects, is just as fundamental as Vulkan and OpenGL. Spiritbe is Khronos' intermediate representation that includes native support for parallel computation and graphics. There's a great white paper. I put the link in there if you're not familiar with Spiritbe. Spiritbe enables the hardware community and the software community to innovate independently. The compiler community can create multiple language front ends. They don't have to worry about the hardware that it's running on. They just have to emit valid Spiritbe. And the hardware guys, they don't have to worry about multiple languages. All they have to worry about is taking in Spiritbe and running it as fast as possible. It means we can have innovation in the language and hardware spaces independently, and that makes for a very powerful ecosystem. So there is a new specification. The new GLSL specification has been released alongside the Vulkan specification itself. It adds the features needed for Vulkan into GLSL. So you should take a look at that if you haven't already. So what are the resources that are available at launch? So there's a lot of material out there. There's the Khronos website. We're trying to signpost developers to everything that's available, including third-party websites. There's already demos and samples that are up there on the website. If you are developing Vulkan tools and samples that you think might be of interest to the community, please let us know. We would be delighted to link to you. Developers get their drivers from the hardware vendor's website as normal. You would go to AMD or Intel, NVIDIA if you have a desktop system, for example, download the drivers, and now they include Vulkan. On the Khronos website, there's two main classes of information. There's what we call the canonical resources. These are the resources that define Vulkan precisely. What does Vulkan mean? The specifications, the header files, the feature set definitions, which is what features within the API different platforms enable, as well as all the reference materials, conformance tests, and the test process. We also have a significant amount of open source materials. There's compiler front ends, and some of the layers that I mentioned earlier, validation layer and the loader, which loads the layer and layer tools layers and will direct commands to the right GPU if you have multiple GPUs in a system. All of that source is available on the Khronos website. Our goal is to enable anyone who wants to create an SDK for the platform, for their system, for the market that they need. And again, we're thrilled that LunarG, who were sponsored by Valve and has been working very closely with the working group, is the first company to ship the Vulkan SDK. And Karen will give us more details on that in just a second. One of the key things is the conformance tests for Vulkan are in open source, and we completed them early enough that multiple hardware vendors have been able to port Vulkan onto their GPUs and pass conformance in time for the launch. So the companies listed here, there are many more coming, and because the conformance tests are in open source, that the developers for the first time can get involved in the evolution of the conformance tests for a native level API. So if you're a developer, for example, and you find in NVIDIA they have differences in their driver because they're interpreting the spec differently, you can actually write a conformance test, and if it gets accepted into the core test suite, you can help solve that inconsistency at the source. So if that's of interest to you, please do consider contributing to the Vulkan Conformance Test Suite. Google have been very active helping us get the test suite engineered, and they've also have taken the test suite into the Android platform tests. So there's a very good working relationship between the Vulkan working group and Google. So it's been just 1 week since the launch. There's been a lot of activity. It's been kind of fun to watch. We have operating systems announcing their support. We have GPU vendors shipping drivers and announcing that their new generations are going to support Vulkan. And I'm sure many of you on Sunday noticed at MWC in Barcelona, the new Samsung S7 is going to ship with Vulkan drivers out of the box, and they demonstrated the first game engine to ship with Vulkan support, which is the Unreal Engine from Epic, and they had a great demo there at MWC. And again, this is of course just the beginning of a lot of industry activity around Vulkan. Even at launch, we had some interesting ecosystem partners. There's a company called the Brenwell Workshop who are creating Metal VK, which is a Metal implementation, sorry, a Vulkan implementation running over Metal. It's still in development, but it'll be interesting to see whether that enables Vulkan applications to run on Apple platforms. And the game that shipped on launch day was the Talos Principle from a company called the Crow Team. They have a beta of a Vulkan backend to complement their OpenGL and DirectX backends. It's still beta, so it's still being debugged and it's not optimized yet, but it is running well enough you can actually run the game, and it's kind of cool that we got to launch day 0 and a real title that was able to run pretty well across multiple platforms. So, as I mentioned, we're not going to go into a deep dive here on Vulkan, but if you're for GDC, there's a lot of sessions around Vulkan, both on the GDC program. There's a link to do the search, and Khronos is running a day of sessions on the Wednesday, March 16th, and you'd be welcome to attend. It's free, no need for a GDC badge. So if you're in San Francisco, please join us. We will also record and stream those sessions too, if you're not able to make it in person. So I want to just finish up by looking forward into the future a little, and to reiterate one of our key messages, that OpenGL and OpenGL ES are not going away. Vulkan is the new API, but there are many applications that will be using OpenGL and OpenGL ES probably for many, many years to come. And they're not in maintenance mode, they're being actively evolved. And so now we have this interesting mix of technologies and APIs. And the discussions inside Khronos are, how can we leverage these technologies? So some of the things being discussed for example, are bringing Spiritbe ingestion to OpenGL. So if in the future we have a C++ shading language for Vulkan, it will be good to be able to use those C++ shaders in OpenGL. Well, if we have Spiritbe ingestion, that becomes quite straightforward. There's a lot of interest right now in safety-critical APIs, and the safety-critical community is interested in Vulkan because it's a small, thin driver, which means it's cheaper and easier to certify. And last but not least, Vulkan has compute today. It has GPU, it has GLSL compute shaders, plus it has the extra flexibility of the multiple queues. But OpenGL has a more compute capability, heterogeneous compute that already a C++ shading language, tiered, precisely defined precision requirements, shared virtual memory, dynamic parallelism. There's an opportunity potentially to bring some of this compute capability into Vulkan over time, so we have one runtime that can do OpenGL class compute and graphics. There's quite a lot of interest in that, and that's, I think, going to be a very interesting discussion. So that's the end of my presentation. So at this point, I'd like to hand it over to Karen of LunarG.
Thank you very much, Neil, for a very good overview. Okay, hi everybody. My name is Karen Gavin. I'm the CEO for LunarG. We're a software company that's based in Colorado, and we are developing an SDK for Vulkan. And so I will spend some time giving an overview to you of that SDK. So as you've heard, Vulkan by design is a very low-level API. And this API, low-level API, will provide applications direct control over the GPU acceleration with minimized CPU overhead and more efficient multi-threaded performance. But since it's a low-level API, a simple program is more lines of code compared to a simple OpenGL program. So as such, developers will need utilities and samples and tools to aid in the development process. So that is why we felt it was really important to have an SDK ready at launch. One of Vulkan's objectives is cross-platform compatibility, meaning that applications written once can be run on many different platforms. The validation layers and the loader and how they behave are key in achieving this cross-platform compatibility. And as such, these pieces, the loader and validation layers, are considered canonical. And Neil had mentioned the canonical term in his overview as well. So these pieces are very important. They are Khronos branded pieces. Inside the LunarG SDK, you will find these canonical pieces in binary form ready for use. The SDK is supported on Windows operating systems, Windows 7, 8, and 10, and on Linux. We tested on a few Ubuntu versions of Linux. Key elements that you'll find in the SDK are utilities, sample programs, tools to aid in debugging, and documentation. The layered design of Vulkan enables a common extensible architecture to install, tool layers for code validation, debugging, profiling, and many other creative uses. And as Neil was hinting to as well, I think we will see some very creative uses of this layered architecture over time. A key fundamental use of these layers is the validation layer that could be enabled during development to aid in the development process. And then when you are ready for production, you can remove those layers and have an optimized performance path. As mentioned before, an objective of Vulkan is this cross-platform compatibility. So having compatible loader behavior across platforms is key to achieving that objective. This loader is an interface between a Vulkan application and the graphics device resources and the layer libraries. The loader will do discovery of the device resources and layers and manages them, aggregates them so that they are accessible in a single application. And by design as well, Vulkan device drivers going to assume the application is using their driver correctly. Hence, traditional air checks that we have seen in other graphics device drivers will not exist in Vulkan device drivers. And so the validation layers are really essential for use during application development. They will provide a mechanism where you can check for correct usage of the Vulkan API during that development process. And then when you're done with the development, you can remove the validation layers for production mode. These layers, today in the SDK, you'll find them grouped into multiple libraries based on some key functionality groupings that you can see listed here. And each of these groupings today will be a separate library within the SDK. To also help with application development within the LunarG SDK, we have some sample programs. These sample programs will do some demonstration of how to use the API correctly. They are written such that much of the code and utilities you'll see in these samples can be leveraged directly for creation of Vulkan applications. We're also including a searchable web index to aid you in finding the samples you need. And yes, the samples will be developed by folks at LunarG, but as well we are taking contributions from third parties for samples as well. VK Trace and VK Replay are tools that are included as well. They allow you to capture a trace of the Vulkan API made by the application, and then you can replay them at a later time. Usually developers will use these tools to capture trace files and be able to share them with third parties to aid in issue isolation without having to provide their application. As mentioned by Neil, the Spiritbe is the intermediate representation that's to be used by Vulkan, and we have included several Spiritbe tools. There's a validator tool which allows developers to convert existing GLSL shaders to Spiritbe, and the disassembler will take a Spiritbe binary and create a textual form of it, and then the assembler will take that textual form and turn it back into a binary form. As well, the Spiritbe remapper, it's used to make Spiritbe files more compressible, which is useful when games have large numbers of shaders and they need to have smaller file sizes. And also, RenderDoc is included in the SDK. During execution of a Vulkan application, you can use RenderDoc to capture a frame that has a defect. RenderDoc will allow identification of the API calls responsible for that defect, as well as more fine-grained exploration of the state of the API before and after those calls. So it's a very useful debugging tool as well. So if you would like to get started developing with Vulkan, you can go to Lunar Exchange at vulkan.lunarg.com and download the SDK. It is for free. You do not have to create an account to download. You can download directly the first page that you land to. However, we do have an option for creating a user account at which point you can create issues, get answers to questions, as well as get notifications of whenever we update new SDKs, as we are continuing to enhance and improve upon it over time. So that covers everything I had. Kathleen, if you want to take it back.
Okay, great, thanks. Let me just switch this back over to you, Neil. And then I can go ahead and start answering questions. But before I do that, I'd like to launch another poll. This time, I'd like to learn about what is the primary target that you are using for your platform. And you can click all that apply. Okay. Looks like we have a lot of Windows people here and Linux as well. So I'll close this and then I'll share the results. You guys can see how you stacked up. Okay, well, I'm going to start with the questions. What anti-aliasing modes are available? And I need to unmute all of my speakers, huh? Let's see, here we go. All right. What anti-alias modes are available?
Vulkan allows, sure. My name's Jeff. I'm a software engineer at NVIDIA. I've been working on OpenGL and now Vulkan. So Vulkan includes conventional multi-sampling modes. I think 4XA is required. I think that may be the only one that's required in the minimal feature set. But implementations can advertise any power of 2 number of samples up through like 64.
Let's see, next question. What about proper text support for high quality LCD that is lacking in OpenGL?
I could address that. This is Tom Olson. I'm the chairman of the working group. Our initial goal in Vulkan 1.0 is to address the functionality of current GPUs and current drivers. So we have stressed the hardware capabilities as opposed to anything that you could handle through middleware. So high quality text rendering, for example, anything involving fonts is out of scope for this level of activity. We think it's ideal for layered implementations and layered APIs that would run on top of Vulkan. Thanks,
Tom. That was Tom Olson. Next question is, what about Apple support? That would be iOS and also OS X. Can anyone talk to that?
Do we have anyone? Go ahead.
Yeah, this is Neil. I can take that one. So the Apple is a member of Khronos, and they're actually on the board of the Khronos group, but they have not expressed any desire or intention to support Vulkan right now. They seem to be mainly focused on Metal. I have no inside knowledge, just observing what they're doing. But from the Khronos' point of view, there's no barrier to any platform vendor adopting Vulkan, should they wish to. So, if at some point in the future Apple wanted to use Vulkan, of course, they would be very welcome to.
Well, and then a kind of a similar question would be about Microsoft and Windows. Will Vulkan run on Windows? And do we know anything about Microsoft's position with Direct 3D and Vulkan?
Tom, you want to take it, or?
Let me make a start, and you can correct me. So this is Tom Olson again. Microsoft has not expressed any intent to support Vulkan any more than they have had more than token support of OpenGL over the past few years. There are well-defined mechanisms by which IHVs can ship a Vulkan driver on any version of Windows. There's a loader that works on any version of Windows. But it will be, as it is the case now with OpenGL, it will be up to an application that is installed that requires Vulkan to negotiate with the implementation to install an appropriate Vulkan driver for the hardware that's on the machine.
Right. Yeah, that's exactly right. And I think, but it's interesting. It is an interesting contrast between the Apple platform and the Microsoft Windows platform. Is that on the Windows, hardware vendors are enabled to ship drivers for whatever API they wish, and Vulkan drivers are already shipping from multiple hardware vendors for multiple versions of Windows. Right now, we have Windows out there from the hardware vendors, everything from Windows 7 up through Windows 10. So even in the Windows ecosystem, Vulkan is available on more versions of Windows than DirectX 12. So there potentially is some value to the developer community in having a single API that spans multiple Windows versions.
Great, thanks Tom and Neil. Another question, what about Vulkan enables good performance on mobile GPUs as well as the desktop?
Could I address that, please? So Vulkan is unique among modern APIs, in my view, in terms of treating mobile GPU architectures and desktop GPU architectures equally. It is possible to write paths in a Vulkan application which will suffer no penalty on a desktop architecture, but will equally exploit all of the capabilities that are offered by a mobile architecture. This is primarily through the render pass and command buffer structure of the API.
All right, great, thanks. Can you talk about what, if any, interaction there will be between EGL and Vulkan?
I can address that one as well. The EGL group has historically defined the context creation and Windows system interface for OpenGL ES. In Vulkan, we made a conscious decision not to separate Windows system integration from the API in quite so strict a manner. So in Vulkan, Windows system integration is defined by a series of extensions to Vulkan rather than by a separate API. We've had extensive conversations with Google for Android and with other platform owners in order to make sure that that mechanism works well across multiple APIs, including Windows. But the bottom line is that there is no EGL for Vulkan. Rather, Windows system integration in Vulkan is handled by extensions.
All right, thanks. Is there any native Vulkan support for multiple GPU acceleration?
I've talked enough. Jeff, would you like to deal with that, or Graham? Graham, why don't you talk?
Is Graham online? I don't see him on the...
Oh, sorry.
I'm sorry, Graham is not on the line.
Jeff, you take it.
Sure. So there is no multi-GPU support in version 1.0. That was unfortunately a feature that we had to cut in order to preserve our schedule. But we do expect it to be near the top of the list for stuff we address in Vulkan 1.1.
If I could amplify a little bit, the way that I view the situation, it is perfectly possible for a Vulkan implementation to expose multiple GPUs. What we can't currently do is allow resource sharing between them. So from the point of view of, for example, a Windows system manager, it's perfectly possible to recognize that I have multiple ways to render to a surface and then can use operating system hooks in order to transfer that to the screen. What we don't have, as Jeff said, is the ability to share a texture or a render target between multiple GPUs. We expect to add that in the next version. It's a high priority, but we don't have it today.
All right, thanks. Will GLSL be the standard shading language for Vulkan, or can we expect other languages to take the place?
Can I take that one as well? Vulkan contains no normative reference to any high-level language specification. The only thing that a Vulkan implementation requires is the ability to accept shaders in Spiritbe format. We have defined, for the convenience of developers, we've defined an extension to GLSL to allow it to generate Vulkan-compatible Spiritbe, but we pose no barrier, and we intend to encourage other mechanisms of generating valid Spiritbe. The SDK, as Neil said, is a set of tools that you can use to validate whether a Spiritbe program is legal for Vulkan and should be accepted by a Vulkan implementation. We strongly encourage developers to develop their own language ports or their own tools, such as graphical tools, such as the Epic engine provides, to generate languages using other high-level formalisms, to generate Spiritbe using other high-level formalisms.
Does Khronos have any CAD-oriented partners who are willing to adopt Vulkan for their applications?
I can talk to that one. We have, there's quite a lot of interest in the professional design community in Vulkan. We talk a lot about games, but Vulkan, of course, is not designed just for games. Any application that is CPU bound that can benefit from Vulkan, and for example, a high-end CAD application that can be manipulating a model with hundreds of millions of polygons very often is CPU bound, and Vulkan can help there. But of course, the dynamics in the professional industry are different. The games often retool often, whereas in the professional authoring industry, there's a lot more legacy code, and that's why it's important, I think, that OpenGL is not going away. So the professional applications will not be left stranded, but if they want to migrate to Vulkan and take advantage of things like the multi-threading for large model interactivity, that is the kind of application that Vulkan is designed to enable.
Thanks. What anti-aliasing modes are available?
So as Jeff said, the Vulkan header file defines multi-sampling modes. So multi-sampling is the basic answer. We have multi-sampling modes up to, I think we have reserved 64x, but we have not defined sampling patterns for 64. We do not have, for example, anything comparable to TIR in the Windows space. That would be for a future version, and we are considering those options, but we haven't done anything with that yet. But multi-sampling is the basic mode. Super sampling, gee, Jeff, do we have super sampling formally supported?
Well, we have per sample shading, which is similar. It's basically the same thing.
Right. So, the Vulkan spec allows implementers to expose multi-sampling and super sampling directly. We require every implementation to support, I believe, 4x multi-sampling. I'm not sure what other requirements we impose, and we don't have anything more complex than that at this time.
Thanks, Tom. I'd like to interrupt the questions and launch one more poll. And this one is asking, what is your main application that you're going to be working on? And again, just choose all that apply. A lot of game developers in this crowd. Okay, we'll close it up, and here are the results. Very interesting. Thanks.
That's actually quite interesting to me. I'm interested to see how many GPU computing applications we have.
Yes.
We are very interested in your input on how good our support is and what you need. This applies, of course, to everyone, but I am somewhat surprised by the number of people interested in GPU computing. We look forward to hearing from you either on the GitHub website or directly as far as what your needs are.
All right, we'll get back to questions. Is a shader or debugging tool, is a shader debugging tool for Vulkan available?
It depends what you mean by a shader debugging tool. In terms of a traditional symbolic debugger, such as you might use with a C++ or C program, the Vulkan working group is not working on any such thing. That would be, such a tool would require very close cooperation from a hardware vendor. And we don't intend to do it, but some hardware vendors may provide that capability. There are excellent debugging capabilities provided by tools such as the LunarG SDK. And we look forward to other products from the community.
In particular, render doc that is included in the SDK would be the best tool currently available for. I'm not familiar with all of the shading debugging capabilities, but I think it has some.
Thanks. That was John Ashford from
right.
LunarG.
Right. Thank you, John. That's a good point. I was talking about symbolic debugging in terms of single stepping through shaders. That's quite a difficult problem. There are such There are examples of such tools that have been developed by individual AHVs, but they're typically rather limited in scope.
Will Vulkan extensions that get used a lot eventually get added into core Vulkan?
I would say, speaking as chairman, that the Vulkan working group is very interested in your input. If you see an extension that is of intense interest, giving us notice on our public GitHub platform through issues is an excellent way to convey your interest. It's very early days. The spec's only been out for a week, but the short answer is yes, but the long answer is please give us more input about what you need.
Are the methods for getting function address, like getProc address, as varied across platforms and as messy for portable applications as those for OpenGL?
Who would like to take that?
I can take this one. This is John Ashburn, LunarG. So if you use getInsta, Vulkan has a getInstance proc address, and that one should, you can, within a Vulkan instance, that will return an entry point that is valid within that for that instance object for any device or instance extension or any core Vulkan command. There's also a get device proc address, and that is particular to a particular device that you have created a logical device, a Vulkan VK device. And so for perhaps a more optimized entry point, you can use Vulkan get device proc address. So it's been designed that you know, if you use those properly, passing in the proper object, it should just work.
So I will add that a top-line goal for us was to get rid of the trampoline context forever. So if you've ever suffered with those, our hope is that you never need to see one again in Vulkan.
Okay, great. Would Vulkan be directed toward web rendering and have bindings for JavaScript stuff, just like WebGL does?
So on that question, the Vulkan working group has nothing to say about that. We are, of course, closely related to the WebGL working group. We are not aware of any particular deep interest in doing direct Vulkan bindings from JavaScript. There is no barrier to it. We certainly won't stop it. Khronos is not currently working on that. Let me see. Oh, well, the other thing I think I would say is that we did consider in the design of Vulkan that not so much JavaScript bindings, but more the question of the WebGL working group, many of whose members are also members of Vulkan. We did consider the needs of a browser. So, for example, one of the features of Vulkan that's notable is that support for opt-in robustness is a required feature of Vulkan. All implementations must support it, and that is there specifically to support, among other things, to support writing Vulkan backends to browsers for any 3D API such as 3.js or WebGL.
Great,
and I would add, it's not quite true that Khronos is not working on it. I think the WebGL working group are beginning to think what Vulkan impact is going to be. There's no decisions yet, but I think the current discussions are headed in a direction that we wouldn't have two web APIs, but rather WebGL would begin to absorb some of the Vulkan functionality where it becomes appropriate for the web, and that functionality becomes pervasively available. So WebGL has an interesting place in the ecosystem because it has to run everywhere, and so including platforms like Apple, for example. So if Vulkan isn't there, then you have to make sure that WebGL can still run on that platform. But that's not a totally new problem for WebGL because there's angle, so you can run WebGL over DirectX as well as OpenGL. So similar kinds of solutions, I think, will enable us to, over time, to help WebGL take advantage of Vulkan-type functionality without breaking backwards compatibility. But again, no decisions yet. That's kind of an active discussion inside the WebGL working group.
Thanks. How much of a platform-dependent code would be needed to write a Vulkan application?
That's an interesting question. The core Vulkan specification has no platform dependencies whatever. We do have the issue that we have brought Windows System Integration somewhat closer to the core in the sense that Windows System Integration is now a core extension rather than a separate API. I am a little at a loss to how to answer. Does anyone else have a suggestion?
I would answer that the WSI, for instance, on Windows versus Linux is mostly the same extensions. There one that is different, so there would be some difference there. A lot of it would be the same calls.
All right, thanks.
Yeah, there's actually, Kathleen, in the there's background material in the PDF that's available up there on the handout section, and there's a little more information around the WSI extensions. And as I've been saying, the standard extensions have been designed to work on across multiple platforms, so Android, Mir, Windows, that's Vista and upwards, and Wayland and X in the Linux space. So from the Windows systems point of view, there is quite a lot of portability.
Okay, great. Are there any plans for a web Vulkan API?
Well, we kind of just covered that. So again, nothing decided yet, but probably we will try to integrate Vulkan capability into WebGL at least as a first step.
Okay. Will the Raspberry Pi 2 have Vulkan support, or the next Pi?
That would be a question for Evan Upton and the rest of the Pi team. We would encourage it. I will say that Broadcom, who designed the GPU for Raspberry Pi, are active members of the working group and are contributing to the definition of the spec, but that's really all I can say. That's
right, and I think it is worth saying that the Vulkan is fully expected to ship on embedded and smaller systems. It's been designed to span all the way down to embedded systems. There are embedded processors that are shipping with Vulkan already. The Tegra from NVIDIA is just one example. So yeah, Vulkan is going to be everywhere.
We could be a little clearer about that. Our specific for minimum Vulkan support is exactly equivalent to OpenGL ES 3.1. So any hardware that supports that should be capable of supporting Vulkan. Otherwise, we've made a mistake. Current shipping versions of Raspberry Pi are not ES 3.1 capable. But as I said, Broadcom is deeply involved, and their GPU team, their GPU driver engineers are involved. They're very aware of the spec, and they have approved it.
What are some of the reasons behind making the WSI KHR extensions?
I should say I'm also chair of the OpenGL ES working group and have been involved in the OpenGL working group as well. We're very aware of the interface problems that were created between the OpenGL family APIs and platform APIs due to the fact that we delegated Windows System Integration to external forces. The fact that, for example, the way that every Windows or Linux implementation connects to an OpenGL API involves a jump table, essentially, that is not part of the OpenGL API. We made a conscious decision in Vulkan that we would bring those things to the surface. So the Vulkan loader, for example, is, well, it's not part of the spec, but it's very visible and very explicit and endorsed by the whole working group. We've done, well, I think that's the primary case that I think is of interest. But our hope is that by sort of claiming explicitly that this is part of our problem, part of the problem that Vulkan has to solve, as opposed to OpenGL, which says it's someone else's problem to solve platform integration, that we at least have a place to solve the problems. We've presented the best solution we're aware of. It's based on variations on the kind of things people have done with OpenGL in the past. If you're not happy with it, again, we have projects on GitHub that we encourage you to post issues to and complain about things that don't work, point out issues, and we will do our best to address them over time.
All right, thanks, Tom. I see NVIDIA has started a C++ interface to Vulkan, which is C. Is this intended to be a standard for Vulkan C++ developers?
I'm only a little bit familiar with this project. I would view this as the kind of thing that we hope to see from the community at large, that people find, or people create, I should say, people create these sorts of layers that they believe will be good for developer productivity and just present a nicer, maybe slightly higher level abstraction of the API, and make them open source and get contributions from the community and just really see what takes off. So I think this is something that some folks at NVIDIA have put out there, and I don't know if it's the first, but I'm sure it won't be the last. And so I think we all hope to see lots of these ecosystem kind of contributions showing up soon.
What Jeff says is exactly right. I think the Vulkan group has tried very hard not to be too ambitious and not to claim any of the high-level space. So we've consciously, I think there was a lovely slide by Neil which showed, compared to the OpenGL space, where the driver spans a wide range from very close to the hardware up to a quite high-level abstraction. In Vulkan, we're doing our best not to dictate those solutions to the community, but to let the community decide what it needs and tell us. So as Jeff said, exactly, the NVIDIA project is a great example of the kind of things we would encourage everyone to try. It's not an official Khronos project. If it turns out to be widely adopted and widely used, we will do our best to support it. But if you have other ideas for the right way to integrate C++ shaders or C++ bindings for the API, we look forward to your contributions and we encourage them.
Will the upcoming Vulkan programming guide be more of a reference or a tutorial?
One observation about Vulkan, because we have, it's a very low-level API and you can use it in a wide variety of ways. We are concerned that developers who are used to an API that is more normative and that gives you more advice about how to use it, we're concerned that people may use it incorrectly. The intent of the programmer's guide is to identify best practices. The example which I'll quote, but I invite other members to give other examples. Vulkan places responsibility for memory allocation in the hands of the application for the most part. We're somewhat afraid that many developers will be tempted to say, well, I need to make a texture, so I will create a texture, and then I will allocate some memory, and I will attach the memory to the texture. We intend a much richer and more complex interaction. For example, we might expect an application to make a small number of large memory allocations and to sub-allocate memory from that for individual objects. That is exactly what an OpenGL driver does when you use it. In the case of Vulkan, we expect the application to do that work because we think the application has more information about what's appropriate. Sorry, that's a bit of a detailed example. I should probably defer.
Well, why don't I just ask the next question, that is there an official GLSL to Spiritbe translator planned?
Khronos will not create that. We're aware of multiple projects in the community through our contacts among developers. People are working on such things, and we encourage them, and we'll do what we can to support you. We're not working on one ourselves.
All right, and I believe this will be our last question. Does the Spiritbe specification guarantee that precompiled Spiritbe objects will run on all Vulkan targets, regardless of the hardware vendor? In other words, is it guaranteed that the developer does not need to tweak the shaders for each hardware platform that they're targeting?
That is our most profound hope for the Spiritbe and Vulkan relationship. We are very aware of the pain that compiler differences have caused in the OpenGL and OpenGL ES environments. We've written the most rigorous specification we know how to write for Spiritbe. If you find problems of that nature, we ask you most urgently to report them. The one caveat I would note is that Vulkan does not specify error behavior. So if you write a Spiritbe shader which does not follow the Spiritbe specification, we are not responsible for what different implementations may do with it. We do provide a Spiritbe validator, and if your Spiritbe passes that validator and behaves differently on different implementations, we want to know about it, we will conformance test it, and we will fix it.
I'd like to add that there are capabilities in Spiritbe which are basically feature enables or feature capability support bits. And so, you know, if you have a Spiritbe shader that works on one implementation which supports some capabilities, and then you run it on an implementation that does not support those capabilities that you're using, then obviously that's not going to work. But otherwise, we do sincerely hope that things are portable and that there's less implementation variation in Spiritbe consumers than there has been in GLSL compilers.
I know I said that was the last question, but apparently I'm a liar. I have a couple more for you. Isn't GL slang an official GLSL to Spiritbe compiler?
Yes, it is. The lead author, John Kucinich, is an active member of the working group. He's also the editor of the GLSL specification. We endorse his compiler. We don't guarantee that it's bug-free, but we do guarantee that we will expend effort to fix it if there are issues. We encourage the use of it. We don't encourage particularly, although you are certainly allowed to create your own GLSL Spiritbe compiler, but we would rather fix the bugs in ours if you're aware of any.
All right, thanks. Could Vulkan be used with Java in the future?
There is no barrier to it. We define a C language binding, and anyone is welcome to create bindings from that to other languages.
Right, and that's happened quite a lot with OpenCL as well. So if history is any guide, that is probably likely to happen, even using Java as a shading language, or a kernel language in OpenCL's case, but a Java to Spiritbe compiler. They're actually open source examples already in the ecosystem.
Okay, well, that is all the questions that I have, unless one of our panelists has anything that they want to add.
I would like to add one thing. This is the first time that any of the OpenGL family languages have ever attempted to present specifications or large software components as open source projects. Vulkan has been available on GitHub for 1 week, and we have currently received over 60 corrections to the specification and corrections to the conformance tests from the community. We are extremely excited about that. We are doing everything we can to be responsive, and we encourage developers who are users of Vulkan to use that opportunity. We pledge that we will give it our full attention and we will address your needs.
Yeah, this is Karen Gavin from LunarG. I'd also like to add to that Tom's comments were in regards to the specification as well. My team and several engineers are, in essence, running the software project around the validation layers and the loader, which also went public last week. And yes, we have already had very active contributions from the people in the community. So and we're putting as much attention into it to be as responsive as possible as well. But it is an open project, and we are committed to working with it and making it work well.
I hope I'm not repeating myself. Is SLI supported? And if so, will it be soon? If not, will it be soon?
There's no direct support for SLI or alternate frame rendering in the API currently that I'm aware of. Multi-GPU support of many kinds is a very high priority. We're very aware of the lack in Vulkan 1.0. All I can say is it will require either large extensions or a new version to address properly. We're very aware of the need, and we are very interested in solving it.
Okay. Well, Neil, I'm going to turn it over to you to close us out.
Yep, I would just like to add a thank you to all of the panelists. Many of us are up late, but we're actually really glad to reach out to the industry there in the Asian time zone. We hope this has been useful for you. And last, I would like to thank everyone who's come to listen. We hope it's been useful for you. There's going to be lots more information coming. Please don't be shy. As Tom has already said, please give us your feedback either on GitHub or the forums or just email. We're really looking forward to what you do with Vulkan and hearing what you think.
All right. Well, thank you, everybody, for joining us. We'll go ahead and close out now. Thanks. Bye-bye.